Thank you for joining us today for this VinTel discussion. I'm Keith McCord, CEO of VinLogx, and today's discussion will cover the VinTel Diagnostic Status Report and how to optimize the use of it for your application. The VinTel Diagnostic Status Report, or DSR, is a universal report that highlights mechanical challenges which the vehicle is reporting via the VinTel OBD scan tool. The status of the vehicle is then used to help understand and gauge mechanical challenges with respect to trade-in valuations, wholesale arbitrations, and other information for customers who need an immediate snapshot of the vehicle's mechanical condition without requiring a technical background. The VinTel platform consists of three major components. Our unique design, made in Missouri, OBD module interacts with the vehicle through the OBD diagnostic port with no user interaction required. This is an important point in that the VinTel system does not require any technical expertise other than knowing how to start the vehicle and how to plug the VinTel module into the OBD port, which is typically accessible under the dashboard. Once the VinTel OBD module extracts the vehicle's information, it communicates via Bluetooth Low Energy with either our VinTel app or one of our integrated partners' apps. These applications run on any Android or Apple iOS-based platforms, including most phones and tablets. And finally, our Amazon AWS cloud-based web portal technology allows access to the diagnostic status report on both the phone apps and through any web browser connected to the internet. Reports can be pulled up through the web portal interface in perpetuity. One of the key features of the VinTel system is its simplicity. You do not have to have any technical experience to generate a detailed mechanical condition report on a vehicle simply by starting the vehicle, plugging in the module, and as you'll see, it takes between 18 seconds and a minute to get a complete report generated and ready to view. The vehicle is started and the module is plugged in. The module will then attempt to communicate with the vehicle and identify it by its VIN. A payload on the module is built specifically for that VIN to test. The test will be ongoing with a green blinking light. When the tests are completed, the blue-green light will cycle, indicating that it's communicating with the phone or tablet. When that is completed, the light will go solid green, indicating that the scan is completed and the module can be unplugged and the vehicle shut off. The data that results from the VinTel module scan is used to create the VinTel Diagnostic Status Report, or DSR for short. The DSR represents the status of the VIN at the time of the scan, as well as any mechanical challenges that are present. These mechanical challenges are highlighted in the Mechanical Information section. Information about the vehicle itself is included in the Scan Information sections, which both will be covered shortly. The Diagnostic Status Report, or DSR, is broken up into two main sections. The first section, the DSR Information section, contains information about the VIN, its decoding through the GALS market data, the information about the module that scanned it, the time it was scanned, as well as what the module scanned. The second section of the Diagnostic Status Report contains the mechanical status information for the vehicle that has been scanned. It is organized such that the most general information is at the top, while the most technically detailed information is at the bottom. This allows readers to consume as little or as much information as the situation dictates. The Diagnostic Status Report Information section is segmented into parts that allow the information to be consumed quickly and easily. This section contains information about the vehicle and its unique report for this scan. First, the report can be customized to allow branding of the report to tie it to your business. Contact VinLogx to add your custom graphics to the DSR reports. The next section in the DSR provides vehicle-specific information about the scan. The unique 17-digit VIN that was extracted during the scan is listed, as well as the decoded VIN information coming from GALS market data to help identify the description in English of the vehicle. Finally, information when available from the specific vehicle is added, including mileage, fuel level, and battery voltage. Battery voltage is important to consider, as most vehicles by OEM rules do not operate properly below 12 volts. Further information can be customized in this section depending on your applications to include things such as stock number, location, etc. The next information section contains information about what was extracted from the vehicle during the scan. VinTel supports two different types of scans. The first type of scan, which we call generic, which is the technical terms modes 3, 7, and A. These tests are generic among all OEMs and typically refer to tests that impact emissions as dictated by the EPA. The second level of testing that VinTel module performs is the OEM-specific test at the controller level. When scanning a vehicle, users will notice that horns can honk, solenoids can click, windows can operate, fans turn on, etc. This is the VinTel system putting the vehicle into a diagnostic mode and testing the components in real time. This unique method for developing a payload to match the VIN is a patented feature for VinTel. The entire scan, both generics and OEM-specific controller tests, take between 30 seconds to 1 minute to perform. The final section contains information about the generation of this report. Each time a vehicle is scanned with the VinTel module, a unique report ID is created and stored in perpetuity. The time the report was generated, the location of the report, the unique report ID, and the unique module serial number, which can be specifically assigned to a person, if need be, is all shown in the report details section. The first section in the mechanical information section is our Icon Dashboard. The Icon Dashboard gives a very high-level overview of things that may affect either the valuation or arbitration of the vehicle. The first icon shown in the Icon Dashboard quickly indicates if there are any exceptions found within the vehicle scan data. An exception is a rule violation dictated by governing bodies such as the EPA, NAAA, or other partners' rules that require you to perform further investigation into this report by continuing down the report information list. If a normal green checkmark icon is displayed, this means that the data incoming from the vehicle falls within normal parameters of the VinTel rule set. The next set of icons is the status of the check engine light, or other OEMs call them the service engine soon light or the wrench light. The status of that light will be shown as either on or off. The next icon indicates if other dashboard trouble lights are on, such as the TPMS light or the airbag light or the ABS light. Again, the icon will show that there are other trouble lights either on or off. Since modern vehicles use fuel as a cooling mechanism for their fuel pumps, VinTel decided it was important enough to include the information if the fuel level is low enough that risks possibly harming your fuel pump and causing a costly repair. This will indicate if the fuel level is below 5%, at which point it should be refilled, or it is above. The final icon is the emission status, whether or not the vehicle passes emissions monitors or has failed one or more emission monitors. Depending on your state, this count will vary. We'll explain each one of these details, including the check engine lights, what triggers it, what passes emissions, what does not, later as we go down the report. To supplement the Icon Dashboard, the VinTel DSR includes the Diagnostic Check-in Summary. This is an English summary of what is going on in relationship to mechanical challenges of this particular vehicle scan. In this section, the status of the engine light is shown. If the engine light is off, you will see the word off. If it is on or blinking, you will see it displayed as on. This corresponds with the status in the Icon Dashboard. This section highlights how many DTCs or diagnostic trouble codes are present on the scan. This is broken down in different statuses as current, pending, and permanent. We'll explain later in detail what each of those statuses mean when we get down to the technical details of the scan. And finally, we show the emissions monitors or system readiness test status of the vehicle that has been scanned. The type of engine is identified, as spark if it's gasoline, or compression if it is diesel. Also, depending on your year, make, model, the available amount of emissions readiness tests are shown. In this case, we show 8 available. It's also shown how many of those tests have failed. In this case, we have 6 that are failed. So thus, this vehicle would not be emission certified in any of the 50 states. Emissions information will be covered in detail later, but it's important to recognize that emissions laws vary by year, make, model, by state and local county ordinances. Be sure to understand the ultimate destination of the vehicle to make sure that it can pass emissions and be registered properly. In the event that an exception has been flagged as seen in the Icon Dashboard, the exception summary will show up on the report. Within this summary will be listed all the exceptions that VinTel has seen on this car as stated by the rules dictated by the governing bodies or our partners. We'll go through some of these exceptions as examples of what we typically see, but these exceptions are constantly changing and we're adding to them as dictated by either the market or by governing bodies. One of the issues we see on about a third of the fleet that we scan is that the vehicles have been reset by a scan tool. This means that a vehicle that has mechanical challenges was taken, plugged into a scan tool, and the codes were cleared. Now, typically, if the repair was not performed, this will pop back up again either immediately or down the road. But we flag this as an exception, and we'll cover the resets as we go further down this report. Another exception that's flagged is if the vehicle has one or more current DTC codes. The DTC codes that are set are covered later in this report, but this is a quick way to know that the vehicle has an exception due to problems. When the VinTel scan determines there are exceptions, we flag the systems that are affected. The reason is that some of these systems are not covered by governing bodies such as the NAAA. So quickly, you can determine which systems are affected by which trouble codes. In the event that the vehicle is flagged for emission failure, it will be noted here. Again, we'll cover more about the emissions testings as we continue down this report. And finally, if the VinTel scan data shows prior crash data present, an exception will be shown. When a vehicle has been involved in an accident that has affected safety equipment, some of the diagnostic DTCs will store history of this event until properly cleared or repaired. If these DTCs are present, they are identified further down in the DSR report and can be compared against any vehicle history reports and or trigger the vehicle to be inspected by qualified personnel. The exception summary is a quick snapshot of being able to look at the vehicle and understand the mechanical challenges with it without having to delve deeply into the diagnostic codes that cause those issues. Part of the OBD spec is tracking reset information. Now, typically the reset information is used when repairing a vehicle by a shop so they can look back and see what has happened in the past. But at VinTel, we decided that this reset information can be used to understand the history of a vehicle and if someone has attempted to manually clear codes on a vehicle in an attempt to hide any mechanical challenges. So in this particular section, we're going to explain and take out the mystery of reset information. Now, the first thing to understand with reset information is the concept of the MIL. The MIL stands for malfunction indicator light. And when a DTC is present, it will request a MIL to be set. When there's no MILs, no DTCs, we present that. Otherwise, what we'll do is we'll highlight, has the MIL been set? How long it's been set? Has the MIL been cleared? How long ago was it cleared? As well as how many times the vehicle has started. So we'll go into each one of those in depth. The first concept to understand on DTC reset information is how long has the MIL been set? In the case of something has failed, and we'll use an example of a catalytic converter failed and the substrate is no longer operating properly. Therefore, the computer sees that the catalyst is below specifications, and it flags that as a DTC. Requests the mill and lights the dash light up. Now, when that occurs, it starts logging how long in distance, and if it does support time, how long in engine runtime this code has been present. So therefore, by looking at the time the mill has been set, some idea of how long ago the problem occurred and how long the vehicle has been driven with that particular code can be realized. One of the wonderful things about the OBD specification is its capability to self-correct or self-heal anomalies that are detected. In our example of a bad catalytic converter, let's say that you had a well-functioning catalyst and you drove through a deep puddle of water, effectively cooling the substrate within the catalytic converter and therefore rendering it below optimal performance. At that point, the computer would detect that the catalyst is no longer functioning within specifications and will set a DTC and request a mill. But then as you went down the road, temperature was brought back up into the substrate and the catalyst started functioning properly. The computer would see that and remove the DTC because it's no longer valid. It would store it as history, but it would clear it. At that point, it would zero out the distance since milk cleared, and if applicable, the time since milk cleared, and the counter would start again. So now you can go back and look to see when was the last time the car had an anomaly and it was either cleared or repaired. This is what that portion of the table does. The last bit of DTC reset information is the engine warm-up since it was cleared. Now, an engine warm-up for most of the OEMs is a complete cycle where the engine temperature, which is done from the coolant temperature, and the air temperature are the same, meaning that we have a cold engine that's sat. The engine is started, brought up to operating temperature, typically 165 to 180 degrees Fahrenheit, and then the engine is cooled back down to where the air temperature equals the coolant temperature. That would be considered an engine warm-up, and that would then indicate that one startup has been completely successful. Now, unfortunately, the OEMs only allow us to go up to 255 starts. So in that case, which is a long time, we indicate it's 255 plus starts in here. Now, when a vehicle is cleared with a hand scanner, this start goes down to 0. That's really the only time that the warm-ups go back to 0. So you can look at and see when the mill was cleared by distance or time and how many times the engine's been cycled through warm-ups to get an idea of how long they've been driving around with this, or in the event of a reset, that they reset it by hand. And we'll cover these examples here in the next slide. In our first reset example, we're looking at a vehicle that was recently reset with a scan tool. Now, the first bit of information we look for when we're looking at reset information is the engine warm-up since milk cleared. In this particular vehicle, it only has 2 starts. Keep in mind, the only way you can reset that back to 0 is through either clearing the DTCs with a scan tool or long-term battery disconnect. Otherwise, if the vehicle is cleared by itself by the OBD, then that never gets reset. So the first thing to key on when looking at a vehicle is the engine warm-up since milk cleared. Our next interesting tidbit on this vehicle is looking at the distance since milk cleared of 0 miles. That means that this vehicle has not been driven since it was cleared. Combine that with only 2 warm-ups suggests that this vehicle was cleared manually with a hand scanner, and therefore we need to look at the permanent DTC records to find out what is trying to be hidden. Our next reset information is an example of a self-cleared vehicle. We know that OBD can self-correct or self-heal, and this is an example of such. Notice that the engine warm-up since milk cleared is 255 plus starts. That's a very high number. In fact, it's a maximum number. So we know that a scan tool has not been used to reset this. So let's next look at how long ago this mill was cleared. The next thing to look at is the time and distance since milk cleared. on this vehicle were at 3.2 engine hours and 18 miles of time since they were cleared, thus indicating this was probably an intermittent problem. To investigate to see if the intermittent problem still continues, we'll do that later when we get into the technical DTC information. But for right now, due to the high number of engine warmups and that it has reset itself and there's no mill present, looking by the mill set, we can chalk this up as to a bobble or an anomaly that is self-corrected. Our final reset example is a vehicle that has an active ongoing problem that has set a mill in a DTC, and the vehicle was attempted to be reset with a hand scan tool. As with the other reset examples, the first thing we want to key on is the engine warm-ups since the mill has been cleared. In this example, it has 3 starts since it was cleared, which means that the vehicle was cleared with a hand scan tool or with a long battery disconnect. That is our first clue. The second clue on the reset status is looking at the time or the distance that the mill has been cleared. This particular vehicle does not understand the concept of time, so all we have is the distance in miles. And in this case, it has been 39 miles since the vehicle was cleared. So combining that with the warm-ups of 3 starts, we know that the vehicle's been cleared by a hand scan tool. So we'll investigate it further to see if the problem still exists. So finally, we look at the distance driven with mill set. In this case, we've seen 10 miles. So that meant that given that they cleared it 3 starts and 39 miles ago, the problem reoccurred 10 miles ago. So thus, we can look at our DTCs to see what is the issue that is causing the mill and what are they trying to mask by resetting the vehicle. Keep in mind that even though the vehicle is reset, permanent DTCs stay until at least 50 to 100 warm-up cycles. So even if someone is trying to reset a vehicle, the permanent or historical data is still present and that's shown lower in the report. The takeaway from these reset examples is this. VinTel will automatically flag as an exception if the vehicle has been reset per the rules dictated by the NAAA guidelines and our work with our wholesale auctions. But it always pays to go back and look to understand why it's been reset. And that is going to be explained further when we get into the technical details of DTCs. But at this point, what needs to be understood is that permanent DTCs, those are DTCs that have been marked and cleared or have been around, cannot be cleared by a scan tool. They can only be cleared self-clearing after between 50 and 100 warm-ups. The reason being is that technicians can use this to repair the vehicle. But from our standpoint, we can look to see if someone is trying to mask something by clearing the car. These are things that they're trying to mask. Understand that. The next section of the DSR deals with the emissions and the tests that are involved with them. Now, typically you have 2 types of tests that are run on a vehicle. We have continuous and non-continuous monitors. Now, it's really up to the OEM to decide what he wants to make continuous or not. Those are misfires, fuel system, and the component test. All the others are non-continuous. But basically, in a nutshell, what it means to anyone who's dealing with a vehicle is that in order to successfully pass an emissions test, if it's required in your local or state region, that the emissions test must be satisfied. And we'll cover what that means in this section. Emissions tests really vary by what type of engine you have. So if you have a spark or gasoline, you'll have one set of monitor tests. And if you have a compression or diesel, you'll have a different set. The VinTel system automatically discriminates between the two and properly lists them as the results. What you see is a listing of the tests that are available. Now, there may be some tests based on your year, make, model, or equipment that aren't there, but those won't be shown to avoid any kind of a misconception as to whether they've passed or not. So in a nutshell, when you're looking at this, you'll try to identify whether the system passes or fails, and what is the cause of it. In this particular emissions monitor, we're looking at the fuel system test, which for this OEM is a continuous monitor. And since this continuous monitor on this drive cycle has failed, it now shows the failure mark in the status. Our next example, the component test, is also a continuous monitor for this OEM. So therefore, you can see that it has a green pass flag, which means that this component monitor has passed its test as dictated by both the EPA and the OEM. It is important to understand the EPA's federal guidelines for emissions. All vehicles created after the year 2001 will only allow one incomplete or failed monitor status. If you have two, the vehicle cannot be registered through the EPA. Now, your state may have enough SIPs that it can override where you do not have to do emissions testing. Some states, such as California, could require you to have all monitors passed. So it's very important that you understand local and state laws, as well as the state law and the local laws where the vehicle is being transported to as its ultimate destination, to ensure that the vehicle can be properly registered with the local jurisdiction. So keep in mind that even though it may not have a DTC, a monitor can fail, meaning that there's a problem associated with a test or a monitor dictated by the OEM or by the EPA that is not passed. It may be indicative of a DTC coming about, but you do not have to have a DTC for an emission system to fail. Now, one of the things to understand is that emissions tests are satisfied by one of two ways. They're either instantly passed or past that drive cycle, or they may require very specific drive cycles to pass. One of the things that occurs when you reset a vehicle with a hand scan tool, or you reset the vehicle by disconnecting batteries for a long battery disconnect, the monitors all reset to incomplete or failed. So another indicator of a reset that has been done with a scan tool is that all the emissions results will be failed and they will slowly start to pass. A few will pass instantly when the vehicle is started. Others could take several hundred miles to completely pass. Again, if you are taking a car in a trade or purchasing a car that has failed emission monitors, make sure you adequately add in the amount of hours it will take to drive the vehicle to get it to pass and become in compliance. Our next section in the DSR deals with the ramifications of mechanical challenges that were discovered on the vehicle and its impact onto the value of the vehicle based on those problems. Now, one of the key points of VinTel, as you've seen, is the entire system is set up to be used by non-technical, non-mechanic people. And this is really where you'll see it shine. We have patented this process, what you're seeing in the recommended cost summary, to where the problems that are dictated by the OEM in very techno speak have been converted into very simple English descriptions to lead the reader into what the problem is, what system or what repair is suggested, what the cost of that repair would be in both part cost and labor hours. So we'll dive into this chart based on our example vehicle next. One of the challenges faced with anyone looking at a DTC report from the OEM description is the vagueness and the duplication of the DTCs. For instance, many times an oxygen sensor may have 5 or 6 different DTCs, but it's still all the same oxygen sensor that's bad. Many people, if you're not trying to repair it, or even if you are, just know you replace the component. You don't need to know why it failed or when it fails. And that's really what you're seeing here. It's part of the special things that go behind the scenes that we have patented here at VinTel, is that we take those complex or vague descriptions of DTCs and we convert them into common English so that we describe them in terms that someone can understand. We point that out is what side is it on, front, back, etc. And we also give a tip of what should be checked and what will be needed to be replaced. And you can see in our example here, the issue with this vehicle says that the catalytic converter at the driver's side is at fault. In this case, it only has front cats. If it had two cats, we would call it out as the driver's side front fault or the driver's side rear fault. We suggest you check for aftermarket parts because this particular vehicle is known to have aftermarket exhaust on it. Check for O2 sensors. Make sure you don't have any of those that are bad, and just replace the catalytic converter. Simple English, simple to understand. The next portion of our patented recommended cost summary is a suggested repair. Now this really falls into three different categories. We can tell you that the part needs to be replaced or assembly needs to be replaced. It needs service, such as add brake fluid. Or it's just information letting you know, hey, the battery needs to be charged. So we break it out so it's easy to understand in English as what the suggested repair is. Now again, this is what we call deduped, so that we don't tell you to replace the catalytic converter, in this case, 3 times. It's the same catalytic converter that may have multiple issues with it. But when you repair it, the suggested repair is simply replace the driver's side catalytic converter. So once the suggested repair to the issue that we have now described in plain, clear, simple English, it's a matter of what does the part cost to fix that, or what does the assembly cost to fix that. So our system, the VinTel system, now has the part cost as OEM parts. Now obviously you could buy something at a aftermarket parts store such as O'Reilly's or AutoZone, but by the rules, especially governed by the NAAA rules which we follow, we list an OEM part. So for a Toyota, it's a Toyota part. That is the cost of the part over the counter. And this will vary depending on what you're doing and what vehicle is being repaired. The final bit of information, after we know the part cost for the suggested repair for the issue, is how many hours it's going to take to repair this. For this, we use the OEM non-warranty labor hours. And you could substitute in your own hourly rate, depending on if you want to repair it internally or send it out to be reconditioned. Completely up to you. But this is the non-discounted labor rate, which you can apply towards the value of the vehicle. To understand the ramifications of the recommended cost summary, the data that is presented in this table is forwarded to our partners such as AccuTrade, who use these numbers to devalue the car based on its mechanical challenges. So if you are tied in with one of our partners such as AccuTrade and using that, that is where these numbers come from. They're passed seamlessly into there and they're referenced for the actual value of the vehicle. And finally, if the vehicle is destined to go to a wholesale market and your auction is an NAAA member and follows the NAAA guidelines, the recommended cost summary numbers are applied to an equation for arbitration such that the part cost multiplied by 70% and the labor hours multiplied by $75 an hour, if that number exceeds $600, then that particular issue could potentially cause an arbitration. So that's one thing to look at if the ultimate exit strategy for that vehicle is going to a wholesale auction. The final section of the diagnostic status report is actually the OEM level of DTC codes. Now this really gets into the techno jargon, and that's one of the reasons why VinTel report places that last. If you're at this point, you're pretty much understanding the ins and outs of repairing the vehicle. And this is where you look to understand what specifically is going on with the mechanical challenges of this vehicle. Now these codes are broken down by 4 different types: P for powertrain, B for body, C for chassis, U for network. So it gives you an idea of what the system is complaining about. Now on advanced codes, we also carry a 2-digit after the 5, separated by a dash. Those 2-digit codes actually tell you why the component is failed or is complaining, and that is appended to the back of the description. For instance, falling time failure, not switching properly, short to battery, etc. But it gives you as much information as you as the end user wish to consume. The next field in the DTC list is the description. Now this is an OEM level description typically written by engineers, and as an engineer, we typically don't wax poetically when describing problems. Thus, the problems are typically described fairly vague or fairly point specific. That is why we have the patented English conversion that you saw in the last slides to help make a little more sense and commonality between the problems. But these are there available for you to look at if you choose to go to that route. Again, the secondary failure cause, the dash followed by the 2 digits, is appended to the OEM level description with the proper ISO SAE approved failure reason. And finally, we have the source of the DTC. Keep in mind when the VinTel module is plugged into the vehicle, it scans a multitude of different controllers within the vehicle. The source tells you what controller is driving the DTC. And sometimes it's a bit surprising, as you will see the ABS computer complaining about engine functions because they're all tied together. And that's the reason why we report it this way. So you can focus on the controller, the source of the problem, while you're fixing the problem. The next set of information on the diagnostic trouble code fields are the information whether or not this particular DTC is requesting the mill light is on. And that's all shown here by icons. For this example, the DTC is requesting that a mill light be turned on. And that can be seen because of the lit light bulb in the DTC field. In this example, the DTC shown is not requesting a mill. Therefore, the icon reflects that. The final topic in understanding of DTCs is the DTC state. Now, there are 3 available states: current, pending, and permanent, or history if you're a Toyota OEM. And every DTC has the capability to set the state. Now, some DTCs, such as ABS or airbags, do not have pending, only permanent and current. But again, the VinTel system accurately depicts that by highlighting which DTCs are active in what state. The first and most important state is what we call the current DTC state. A current DTC state means that this failure has occurred on this ignition cycle or the last time it was tested. This means that this is an ongoing problem that needs to be fixed. The next state for DTCs is the pending state. The pending state basically is an intermittent state or a DTC that has not matured to a current due to the amount of times that it has been seen. The OEM and the EPA both dictate what that level or that threshold is, typically 1 or 2 test failures. Now, what's interesting about pending is if a vehicle has been reset, and you know it's been reset by the reset information, look to pending to see if DTCs are marked in pending, because those are now occurring again even after the reset, which leads you to believe that it probably wasn't repaired and someone is trying to mask a problem, which will most likely mature to a current and throw the dash light on. The final state for DTCs is a permanent or history state. The permanent state of a DTC is set when the DTC has been detected. They do not clear until a certain amount of drive cycles or warm-up cycles have been completed. Typically, that is at a minimum 50 cycles up to 100 cycles. They cannot be cleared by a scan tool. So therefore, if you suspect the vehicle's been reset or you want to see if it's been repaired, what has been repaired, look to the permanent codes. It will give you an idea of what has happened in the past 50 to 100 drive cycles. So why use the diagnostic trouble codes? It's a great question. You already know in plain English terms simply what parts have to be replaced as well as what the labor is. When you get to this level though, you're typically trying to understand why these DTCs are happening and when they're occurring. So you're looking at states. Is it a current? Is it pending? Is it something I have to worry about maturing as they leave my car lot or as I just bought on the auction? Furthermore, if they say it's been repaired and I don't have any current, I don't have any pending, but I have a permanent code and I have some drive time on it, well, I can pretty much know that that problem was repaired satisfactorily. So it's really diving deep down into the details to understand the mechanical challenges of the vehicle and whether they've been addressed, they're being hidden, or they're still present. This concludes our discussion on using the VinTel Diagnostic Status Report to help understand the story the car is telling. If you have any questions, you can reach out and contact us at the information below. Thanks again for listening, and we appreciate your time and your business.